Hi, my name is Mary Ann Naif, and I'm chair of the Harpswell Climate Resiliency and Sustainability Committee. We have some other members here tonight as well, Jane McCrate, Nancy West, and Deirdre Strachan. And we have Jenny Zagarello, who is also on the Conservation Commission, and we do this project hand in hand. So just like to welcome you tonight. Before we get started on really the important stuff that you're here for, I just wanted to talk a little bit about, next slide, a Maine Won't Wait update. Basically, our project tonight is the result of Maine Won't Wait. We received a Governor's Office of Innovation and Technology grant to fund this project for Will Haskell to do the engineering study for Abner Point Road and Bethel Point Road. They have updated their plan, and just last week they came up with the second, it's a 2-year plan, and they're coming up with the second update. And they did focus more on making Maine more resilient to the impacts of climate change. And this kind of works into what we have been doing here in town. We became a partner with Maine Won't Wait in 2022, at which point the select board actually, signed on to the climate action plan, of which we listed a number of items that we wanted to really focus on just for sea level rise and climate change. We became a member, and the first year we were able to have a grant where the town was able to fund all LED lights being put in the town office building here. And also a energy audit. This was a project that was worth approximately $45,000 to $50,000. Those have been done. And the second year, we were able to apply for this grant, which was to look at Abner Point Road and Bethel Point Road, have an engineering, more of a better study to see just what the costs are going to be and what our options are going to be going forward. Next slide. Mm-hmm. So basically, the new plan, they are focusing more on immediate actions to improve storm surge, not so much continuing to look towards the future, but they're going to be funding more action items to take care of damage. And also, we want to integrate our planning into long-term, which we are hoping this plan that Will has worked on is going to put the town in a position to know what costs are going to be going forward over the years. And I see someone sitting on the Budget Advisory Committee here who should be very, very interested in that type of thinking. So next, I believe the next slide, I thought there was some interesting statistics here, that in the past 4 years, we've had among the 10 highest seasons of temperature on record. We've had 1 to 2 additional days per year with 2+ inches of rain per storm. And the winters are 2 weeks shorter than they were between 1901 and 2000, none of which everybody living here has very much realized, I'm sure. So now, and rising sea levels, they are 8 inches higher than a century ago. So while we seem to be more affected by storm surge with high winds on a king tide, with more southeast storms during the winter, wetter storms, we are seeing more property damage and so forth. So at this point, I would love to turn this over to Will, and he's going to run through what they were able to find out for both Abner Point Road and Bethel Point Road. Thanks. Oh, and we'll keep questions to the end, I think, because we do have people on Zoom. Thank you.
Great. Thank you, Mary Ann. Again, my name's Will Haskell. I'm a civil engineer with the firm Goral Palmer. We're based out of South Portland. And we've been doing a number of projects for the town over the years. Variety of different projects, from roadway projects to these resiliency projects more recently. We're also working on a couple projects that are storm damage repairs from the last January storms. So we're looking at, we're doing some work over at Little Islands Road, and we're also doing some work down at the end of Ocean Street, the trail to the giant stairs. There's some significant erosion there along the embankment that we're taking a look at. I think both of those projects have some FEMA funding associated with it because of the damage and the disaster declaration from the January storms. But it all ties into these projects. So we're working on this project for Bethel Point and Abner Point, and we also have another project for Lowell's Cove Road and Dingley Island. So that will be coming next. There'll be another or some more meetings on that as well in the next in the coming months. So. So with this project, I think we had an initial kickoff meeting back in January of this year, end of January. So it was appropriate right after the January storms that we had on January 10th and 13th. So I think it was front and center in everybody's minds in terms of what could be coming down the road with significant storm events. We also had a status and an update meeting in June, towards the end of June, where I think we mostly focused on Abner Point Road during that meeting, but basically gave an update of kind of where we were at. So again, purpose of this meeting, there's public engagement that's required as part of these grant applications. So we were required to have these public meetings to get input from you folks and incorporate that into the plans as we move forward. So project goals here, we're basically reviewing and evaluating adaptation alternatives at both project locations. So looking at ways that we can make these roads more resilient. Both of Abner Point and Bethel Point Road at Hen Cove went underwater in the January storms. So we're looking at alternatives to make those roads more resilient. Obviously, when a road goes underwater for any period of time, there's concern. You can't get public safety vehicles down those roads. They're both dead-end roads. There are a number of concerns that go along with that, just in terms of, everybody getting access in and out. If there's businesses involved, it's lost time associated with the businesses as well. So these two roads are at least a couple of the lowest roads in the town. There may be a couple others that are in a similar situation, but I think Bethel Point Road is the elevation of the road going across the causeway there is around 9.5 feet, and Abner Point is around 8.5, 8.4 feet at its low point down near the boat launch there. So when you look at the FEMA flood elevations, they're significantly higher than that.
Recording in progress.
And we'll get into that as we go through some of my slides here. The Maine Won't Wait documents that Marianne was referencing, the first one that came out in 2020, talked a lot about different levels of sea level rise in terms of managing and considering different levels of sea level rise over certain periods of time. So I think the number that we've kind of been focusing on, which is 3.9 feet, kind of an odd number, but let's round it up to 4. But, looking at sea level rise of 4 feet, potentially in 100 years down the road, essentially. But, so it's a longer planning horizon, but as we've seen with these roads going underwater more frequently, it's a real thing. And you don't need 4 feet of sea level rise to cause problems here, especially in a town like Harpswell with such a long coastline. So again, identifying impacts and permitting requirements. These projects are complicated. While you would think it might be relatively straightforward for public safety, there are environmental issues that we need to deal with whenever you're talking about raising roads or relocating roads or pretty much anything to do with roads is going to have a permitting implication through the Maine Department of Environmental Protection, possibly U.S. Army Corps of Engineers, multitude of other agencies that get involved, and with updates in the rules that are currently in the works through the state. There are other agencies that are actually having more input on environmental concerns and impacts depending on where you are along the coast. So Maine Geological Survey is another agency that is having more input, especially in areas where there are dunes, which I don't think we have any dunes in these two projects, but there are definitely other places along the coast where we have impacts to sand dunes. So, and then a big thing with this is what's it all going to cost? These projects have significant cost implications. There's a lot of earthwork, a lot of infrastructure work associated with these projects. When you start looking at raising roads, replacing large culverts, it's significant, and the costs aren't going down any either. So they've gone up substantially since the pandemic, and it keeps going up pretty much on a yearly basis. So not necessarily an easy thing to estimate in terms of the cost of these projects, but we have a lot of information based on current bid pricing and other projects around the state. So we think we can put together some good estimates of cost on the various alternatives. So I'm going to start with Bethel Point Road, go through some bullets here on this plan, and then on this sheet, and we'll get into some plans to show you what we're looking at. So Bethel Point Road at Hen Cove, there's an existing culvert there under the causeway as it goes over Hen Cove. That culvert was actually replaced in 2013 with a 12-foot span culvert, a box culvert, 12 feet wide by 10 feet high. And as I indicated before, the elevation of the road there is around 9.5 feet. FEMA just updated their flood maps this past year in June, and if you look at the revised FEMA flood map at this location on the ocean side of Bethel Point Road, the elevation is 12 feet, and on the non-ocean, these elevations are, that's a very good question. There's a lot of datum confusion with elevations, so they're not related to mean high tide. These are NAVD 88, so it's a survey datum. In terms of tying that to high tide, I should have brought my little magic. Yeah, it's about 5 feet different. So, so it's one of the challenges that is confusing in talking about these projects is because I think most of you are more used to dealing with the high tide elevations, but
Is the 9.5-foot current measure, is that in the same datum?
that's, yes, all the elevations in my report or my presentation are all tied to the same datum, so I'm not mixing and matching datums. Yeah. Causeway is about 170 feet long. So we've looked at a number of things here, and I guess one of the interesting things with these two projects is there aren't a lot of options for us in these cases. So the primary option that we've been looking at is raising the road. In this case, we can raise the road, we can make the culvert bigger. We've looked at rerouting the road around the cove in this location. We've essentially discarded that option for a number of reasons. Environmental is one. There's land trust land in and around the cove there that would be challenging. Other private property impacts and the cost. It's a significant reroute. Quite a long length compared to going right across the cove there at the pinch point, and I guess cost wise, I just off the top of my head that project there would, without even considering purchasing private property or easements for private property, would probably be 3 to 4 times the cost of raising the road. So it's a substantial cost outlay for looking into that. So here's the current flood map. I just wanted to bring that up a little bit so that you can't really see the road in here, but it essentially comes down and crosses over the cove here. Hen Cove Road comes off right here. Sage Road, which is a private road, up here, just trying to orient you to everything. And Little Ponds Road is right here. So the ocean is down in this direction here. So what we see on this map is this VE zone, elevation 12, which I mentioned, basically falls in between these white lines that I'm kind of outlining with my cursor here. These maps are very interesting because on this side of the white line, it's elevation 14. And so just a little bit of description of FEMA maps. VE is a velocity zone, and it's where you'll see waves impacting the base flood elevation. And as you move in closer and closer to shore, usually that elevation will drop down because you're getting more friction for the water as it comes in, and those waves aren't breaking as high. So, but what that shows is that over the bridge there, or over the culvert, the elevation of the base flood is elevation 12, which, as I said, the road is 9.5. So you've got waves basically breaking over the top of the road in that case. As you get into the little cove on the other side, that elevation changes. It's not so much driven by waves at that point. It's more of a quiet, just elevation of water, but so that drops down to elevation 11 there. Let's take a second to come up. So zoom in here. So again, sorry, there's a little bit of in terms of orientation of the map here, but the road basically comes in Hen Cove Road here. We cross over, the culvert's located here, and then this heads down towards the dead end of Bethel Point Road. So sorry about that. What we're showing here is that we would need to reconstruct roughly about 580 feet of roadway to raise this road up by about 4 feet. 4 feet isn't going to get us exactly to the FEMA flood elevation. It's still a little bit shy of that. But it would raise the road about 2.3 feet at the low spot, 2.33 feet higher than what it is today. We can do infinite number of options here in terms of raising this road. We picked 3.94 feet just because that's what Maine Won't Wait has kind of been focusing on as an elevation. We could pick it up to the FEMA flood elevation if that's what everybody wants to do. It's just going to cost more money, and it's going to result in more environmental impact. That's going to cause more permitting and challenges with the regulatory agencies if we were just to go through and actually design and permit this project. One of the things we heard at the first public meeting, the kickoff meeting, I believe from the gentleman who lives at this property here, was concerns about whether the existing culvert is big enough to handle the flow. Well, it definitely isn't in terms of for storm surge. So there are a couple things you can do. One thing is you can go and you can build a bridge from one side to the other. You could span this whole thing. I think cost-wise, that's probably going to, it's probably not going to be a feasible option. So we looked at a couple interim options. One is putting in a 25-foot span, so essentially more than doubling the span of the existing culvert. And then we did another option where we looked at a 50-foot 50-foot bridge, so basically spanning the pinch point, if you will. But we're not going from one side all the way over to the other side, but we looked at a 50-foot span in there. There would have to be more modeling, hydraulic modeling done to look at the impacts of those and to see, how much of those, those two different options, are they going to improve the hydraulics and the flow through there? When I step back and look at it in the big picture of things, though, no matter what bridge you put through there, if the elevation of your road is below the FEMA flood elevation, doesn't really make much difference what the width of the bridge is. The water is going to go over the road at some point in time. So, so you really, to me, raising the road is probably the first thing you want to do there versus lengthening the bridge, if you will.
Can you look at erosion on either side?
What about?
The erosion on the land on either side of the bridge. Because when the storms happened, it wasn't just over topping the road, it was
Yeah.
kind of eating away.
Yeah, so part of our cost estimates are we add in erosion control, we'll add in more riprap to protect the embankments, if you will, on either side of the bridge. That's really important, is to have the correct, appropriate armor on either side to deal with that storm surge. And waves obviously have more power to them, or more force associated with them than just water that just kind of goes up and down, without the surge associated with it. So that's an important piece that goes into our calculations on the cost of these improvements. So this option here is raising the road 3.9 feet and a 25-foot span culvert. You're basically looking at about $3 million for 580 feet of road. And then the bridge brings you up to a little over 5.15, $5.2 million, say, if you want to round it up. So again, these are conceptual cost estimates. They're not, we don't have a lot of detail that we're working with, so we feel we've added in the appropriate amount of contingency. You can see down here, we actually do have a contingency line item, and typically at a conceptual level, we include a 20% contingency there, which is, it's a big number, $767,000. So, but we have to have that because there's just so many things that are unknown at this level. So you'll see that pretty consistently when someone gives you a conceptual level cost estimate.
Did you do an estimate to bring it up to the FEMA level?
We have not done an estimate to bring it up to the FEMA level. If that's of interest to everybody, we can include that in our final report. So after this, we're going to write a final report, and we can add that into the final report.
Some useful information to have.
Yep. We've also included estimated engineering and permitting fees in here, so we've tried to be, you know, as thorough as we can in coming up with these numbers. Any questions on this before we move on to?
What is the FEMA level again? The FEMA flood?
Yeah, FEMA elevation here is 12,
Right.
and we're getting up to, let me go back to my plan. We're basically getting up to 10.6-ish, so we're about 1.5 feet still below the FEMA flood elevation. It depends on which side of the road you're looking at, though. On the other side, it's 11. So we're about 0.4 feet away from that one.
If I might just say something here, I think this type, as we know, is a high-level engineering analysis. But it does give the town an idea of when they're planning and when they're ready to move. We would then go out for an engineering design and build, which would be, give you more exact figures. But this is a planning tool that we're using, looking out the next 20 years or so to see where we're going to have to concentrate our resources.
And these numbers, again, are this year's numbers, too. It's not projected out, because we don't know how far out the town is, you know, if the town is ever going to pull the trigger on a project like this. So it's...
So when we had discussed this project at the last meeting, another issue was brought up, and that was that there was also flooding about maybe 200 yards down from the bridge, where the creek from the marsh comes and crosses a culvert underneath Buffalo Point Road to go into Swamp Cove there. And it still doesn't seem to make sense to me to spend $5 million on this project when you're not going to actually end up solving the problem of access if there's additional flooding going on down the road that wasn't addressed at the same time. And I know that you kind of resisted talking about it because the funding wasn't directed towards studying that part of the road. But before the town spends $5 million to fix this spot, it seems to me that something needs to be addressed at the other spot.
I understand your point. Most often with projects like this, though, I mean, the town may not be able to address both of those projects at one time anyway, so they would have to be addressed potentially sequentially. Which one gets addressed first? I mean, again, it's really up to the town. I guess they could be lumped together into one project. It would just be a bigger bond and a bigger project for the town to take on, so.
Right, and we heard you last January about that, and what we are trying to do now on the committee, in fact, is we are applying for a grant, the end of the week, to take the FEMA floodplain maps and do a better analysis of what the storm surge, wave run-up and everything are going to do town-wide. With the thinking being is we are then in a position to start zeroing in on places such as you mentioned on Bethel Point Road. We have been focusing on all areas that were basically culverts over coves, et cetera. But we're hoping with funding on that, we are then in a position to start concentrating and studying areas such as that, and I'm sure there's others in town that we're not aware of, to put us in a better position to study further. Here again, as I mentioned, I hear what you're saying. And we realized we have focused on the 4 or 5 lowest point roads in town that are affected now, but there's roads leading up to them. And there's other places that will flood over. So I've heard what you said.
Yeah, Harpswell, I mean, not unique, but I mean, it definitely, there's just a lot of infrastructure that is directly impacted by this coastal flooding here. So the town has just a much larger number of these situations that they have to try and deal with and address. So it's just hard to work on them all at the same time. And I applaud the town for being very proactive in terms of going after the grants to do this work and to start to look at it, because if you wait, it's just going to be that much harder to get it done on a timely basis. So.
And also, periodically, most of these are planning grants that we have been applying for, but just last spring, there was a grant put out by Maine DOT that you could, they were going to pay 95% of construction costs.
Up to $4 million.
Up to $4 million.
Yeah.
So we applied for it, we didn't get it. But we had a couple of projects on town landings that would have paid for raising those landings. Unfortunately, we didn't get the grant, but we were in a position with these type of studies to go ahead, because they come up out of the blue. And then we can use also SPIRA to do the match that we might have to show on a grant like that, on a project.
And I think your the Lowell's Cove Dingley grant was a infrastructure adaptation
Yes,
grant.
that was also, but that was
It's
just
a
planning.
planning grant,
Yeah,
but
right.
it sets you up better for the construction grant if you decide to
Right.
pursue that, so.
How did you come up with the 2.5 foot rise rather than the?
So what that is, yeah, it's basically that 3.9 feet above this highest astronomical tide line. That's where that came from. And it was really all about just tying it to that Maine won't wait guidance. We can pick anything we want. It's just at some point you have to decide how many of these are you going to look at. We initially started looking at 1.5 feet, but 1.5 feet puts you right at what the current road elevation is. So we said, well, we'll at least go to 3.9. But we could easily do a cost estimate for going up to, elevation 12 as well. And it won't take that much effort to put together a cost estimate to go up to elevation 12, which is the FEMA base flood elevation. So the interesting thing too is when we started this, the new flood maps weren't active yet. We were still looking at the old flood maps. And so probably back in January when we met the first time, we may not have had that elevation 12 on here because I think we were using the old elevation, which was quite a bit lower. It might have been elevation 9, for example, or 10. So there's been a little bit of change over the course of the project here. So,
Yeah, those were the floodplain maps that the town voted on in June, I believe it was, June of 2024.
yeah,
And we are
when-
now using those.
And at Abner Point Road, if you didn't go with the revised map that the town had another consultant look at, the elevation in there was for the original FEMA flood map was significantly higher. It was like elevation 21 or something like that instead of, and it was just like, yeah, you can't raise the road high enough to get up to that elevation. So
So maybe go on to Mackerel Cove next, and then we can take roundup questions about this project as well at the end.
all right, so Abner Point Road, boat ramp was replaced in 2019. Road elevation at the boat ramp or around the boat ramp is around 8.2. And the FEMA base flood elevation there is, again, it's a VE zone, so it's wave, impacted by wave, storm surge, elevation 14. Raising the road at this location, there's a number of, the several private properties that are impacted. We looked at a couple different options here, and we'll get into these. I've got a little video, if I can get it to work, to show you too. So one option that we're looking at here, rather than raising the road, is looking at a portable flood barrier. So there's a number of portable flood barrier companies out there. They make different ones. This one caught my eye. If anybody's familiar with the town of Damariscotta, they're doing a bunch of work up there on their town parking lot that are kind of in behind the buildings there off of the main street. They're putting in an underground detention system in there, but they're also have purchased, I believe, one of these portable flood barrier systems that can be deployed before an anticipated high tide event, and basically when the water comes up, this thing automatically kind of raises up and creates a dam that basically prevents the water from impacting the properties. So I've got a few slides here to show you that. This company that we've been looking at is actually, it's based out of Quebec. They have a product called Watergate. The company's called Mega Secure. Pretty interesting product. There's a number of other companies out there. And cost-wise, comparative to raising the road, it's a pretty significant difference in terms of a savings. Yeah.
You have to worry about water coming in from the other side, though, on average.
You do. The one thing about Abner Point Road with the water coming in from the other side, though, is at least what we've been seeing, and probably need more of your folks' input there, but is that most of the storm surge and the storm events are coming from the cove side, Mackerel Cove side, not the other side. There's a nice, fairly large wetland system on the other side that actually does a pretty good job of dampening out any storm surge in there. Yes, there's potential that the water could come in from that side, but I think the most significant storms that you're going to see are going to be coming in from Mackerel Cove. So why don't we, did I see another question? Did you have a question? Okay, all right. These barriers, you can get them in different heights. This one comes up to as much as 60 inches high, so 5 feet. We looked at a couple different options, the 39-inch and 50-inch high options. You can actually connect the different heights together. So in this case, where we've got kind of a sag in the road, you can put your 50-inch high down at the low spot, and then you can tack on a couple 39-inch high pieces on either end, and create a barrier that essentially does the same thing as raising your road up 4 feet. We also looked at raising the road 4 feet, and then another thing that we looked at was down at the low point, right at Luby Lane. There's a cross culvert that takes the ditch water from Luby Lane and discharges it out to Mackerel Cove. The elevation of that culvert is about 2.5 feet below the low point in the road. So when that water starts coming up in the cove, it actually backflows through that culvert and starts flooding out the opposite side of the road before the water ever gets even close to going over the top of the road. So there's a couple things that we can do there that are relatively low cost. We can put in a what's called a tide gate valve. There's a couple different types of tide gate valves. I'll show you some pictures. And basically what that is, it's a check valve essentially, and it basically keeps the water from backflowing through that culvert, and will at least give a little more time, or will prevent that water from backflowing through there and flooding out the other side of the road for a little bit longer if you put that piece of infrastructure in place. So it's a relatively simple solution that doesn't solve the problem by any means, but it may deal with some of the lower level events that might occur and keep that from flooding on the other side. So we've got some information on all three of these, so I'll keep going here. And again, this is the flood map. Just wanted to show that to everybody. So here's Abner Point Road coming around the head of the cove. Again, a lot of different lines here. Out in this area, the VE zone elevation is 17. Over here, it's 21. In here, which is what basically impacts most of Abner Point Road, is VE elevation 14. A little bit higher than Bethel Point Road. And then as you can see on the other side, it changes. This AO depth 3 seems a little bit odd to me. I have to look at that. But we have the VE zone over here that's 13 that comes up into that wetland. So you can kind of see that wetland does as I said, kind of does a good job of kind of dampening out those surges from the other side. So these are a couple tide gate options. I wanted to show you this product here is actually a rubber, I call them a duckbill. It's called a tide flex valve. It gets attached onto the end of the pipe. Basically, this curved piece at the end is there's a slit here, so when water backs up and builds up on the upstream side of it, it basically forces that duckbill out straight, and the water kind of flows out through the end of that. But it prevents the water from coming back in this direction. So you would put this on the Mackerel Cove side of the culvert, and it would prevent the water from Mackerel Cove from backing up through that culvert to the Louis Lane side of the road.
How resilient are these mechanisms to debris?
So this actually works really well with debris. Debris really doesn't impact it too much. I mean, I guess if you had a huge mass of seaweed or something build up here, it might impact it a little bit. Which I know there is a lot of seaweed that builds up over there. There's a couple things that we could do for that might increase the cost a little bit to kind of prevent the debris buildup on it. This is what's called a flap gate, again, attached to the culvert. These things tend to be pretty noisy. These gates have some weight to them, so as the water builds up behind that gate, it doesn't open immediately. You know, it will tend to surge out of there, so it will like kind of flow out, and then that gate will come back, slam back down into the as it seats again, and it tends to make a kind of a slamming noise every time that thing opens and shuts. So you have to kind of be careful in terms of where you want to use that type of a product. I did see some out there that are rubber coated or different types of systems to try and minimize the noise associated with those. But yeah.
Are these used anywhere on Costa Mesa?
We've used the tide flex valves a lot down in Portland on culvert and storm drain outlets discharging to to the bay or to Back Cove. The ones that I'm more familiar with, the last one I installed down in the city of Portland was 82 inches in diameter. So it's a little bit bigger than this one. We're looking at a 15 or 18-inch pipe coming underneath Abner Point Road. So it's a little bit of a different animal, but they are relatively common in coastal areas with storm drains or combined sewers or things like that. So let's see here.
How durable were they in the January storms, the ones you're aware of? Did any of them fail?
No, not that I'm aware of. These rubber valves are pretty impressive. They're highly engineered. They're definitely made to work under very challenging conditions. It doesn't. It's interesting because in this case, and in a lot of cases, you actually have water built up on both sides of these. You've got the water on the downstream side that's built up, and then you've got water building up on the upstream side. And they're designed to open more easily with the pressure of the head on the upstream side. And even if there's if the water on the downstream side's higher, then yeah, you're not gonna get it to open because of hydraulics. But they're definitely built to withstand impacts from logs, from rocks, from debris hitting them regularly. So they don't fail very often. This type of a valve here, you can get things that are caught in here, so it actually it stays open more often than the tide flex valve would, and that kind of defeats the purpose, because if it's propped open, then you're just going to allow that water to kind of go back through. So we've had very good luck with these. They're used a lot they come in all sizes. So I mentioned an 82-inch diameter one. You can get them as small as 3 or 4 or 6 inches. They're used a lot in wastewater treatment plants to keep flow from, not going where it's supposed to go or flowing backwards through the system. There's a lot of, debris and sediment and things in those types of systems, so they're designed to operate under pretty difficult situations, so. So this is the few slides here. We actually met virtually with the folks, this Watergate product. So this just kind of shows how these products are kind of delivered, kind of rolled up. It's just pretty straightforward. They've been in business for a number of years, I think since 1998. Again, they're based up in Quebec. There are several other companies that do similar types of products. Let's see, for some reason I'm not, there we go. So this picture here just kind of shows, so it comes kind of rolled up like this. There's actually different types of crates and things. You can actually buy a specific trailer for these things and just basically drive it down the road and kind of roll it out the back when you're deploying it. But you basically unroll it, unfold it. Looks like this sitting on the ground, so the water would be coming in this direction. This is a weighted edge here. It works pretty well. It works well over kind of a wide variety of terrain. It doesn't necessarily have to be set on pavement or anything like that. You just can't have like a log or something going underneath it that provides a gap underneath here for water to kind of pass through. But basically the water comes in, fills up these little scoops here, if you will, and then this section kind of raises up, and you can kind of see that in this image. And I've got a video later on that I'll try and show you. But the water comes in and just automatically floats this up, and this basically, depending on which size you buy, acts as the dam, the temporary dam in this case. This is a deployment crate, so you can buy it in these crates. We talked to the folks. In this case, we thought we'd need about 500 feet of this stuff. It would come in 3 crates, one crate with 200 feet and 2 crates with 150. Basically, we'd be loaded into a back of a truck, and you basically just pull this product out of this crate and lay it down on the road. Unfold it, and then you basically let the water do the work when the water starts coming in. You can see one of them here deployed. I think this is along a river, but so it can have angles in it. It doesn't have to be in a perfectly straight line. They do them around houses, around buildings. They're used in all kinds of situations to prevent flooding. The other thing is if for some reason it was deployed across a road, they have pictures of emergency vehicles driving over them when they're partially deployed. It doesn't really hurt them at all. They can drive up and over those things, and doesn't do any damage. When the water goes back down, that's probably the most challenging piece, because you kind of got to let it dry out, and then you've got to kind of pack it back up and put it back in its crate. But hopefully it's not something that you need to do every day. They say it can be deployed, by as little as 2 people. Typically, 5 people would deploy something like this. And I said those deployment crate of 200 feet long would typically take about 15 minutes to deploy. So you could deploy all 3 crates within 45 minutes or so. So this is where I'm supposed to have a video. I'm going to wait till the end to show you the video because I can't activate it here in this PDF that I have. But I guess I could go try. Let me see if I can get to my video here.
How does it do in windy situations?
What's that?
How does it do in windy situations?
It's pretty heavy duty fabric, so it's not. And if there's water in it, I don't think the wind's going to impact it at all. And when it's flat before the water comes, it's that really heavy. Not really sure what they call that fabric, but let me see if I can get this going here.
By using this unique self-opening method, it reduces the time, effort, and number of people required to install it, making this a truly rapid flood or water diversion barrier. The WL Series water gate has a weighted front edge which holds the barrier in place and helps prevent water from leaking underneath. The barrier uses a type of stitching called lock stitch. A broken stitch will not compromise the remaining stitches. The barrier is easily and quickly rolled out, ready to be used. It is very versatile and can adapt to different environments. The water gate can be driven over thanks to its flexibility. It is highly portable and takes up barely any storage space. The barrier can be transported in a vehicle or truck to the designated site.
There we go.
What's the height of water that can absorb?
Yeah, so you can get these up to 60 inch. They'll go up to 60 inch, 5 feet. At Abner Point, we were looking at 50 inch, just over 4 feet. Down in the low spot, kind of right in the vicinity of the boat ramp, about 100 feet of 50 inch, and then I guess 400 feet, 200 feet on either end of that of 39 inch, which is the next height down. So they come, I think there's one down below 39, then you got 39, 50, and 60. So those are kind of your options. Again, there are some other companies out there that we haven't looked at. We were just kind of trying to present one option here. There are other types of these things too that are more, instead of fabric, they're like plastic barriers that are like L-shaped in that they kind of link together and you kind of build them similar to this. But I kind of like the automatic kind of, as the water comes in, it fills up and then goes back down. And just the ease of deploying it, rolling it out versus trying to fit these things together. And
Seems like it would work best with a slow rise of water rather than storm surge with wave action and that sort of thing.
it would, but I think, I also think that while you will get storm surge here with the waves coming up over the road, I think those waves are still going to be quite a bit lower, and because you're still a little ways away from the actual normal high water line or high tide line here. And I still think it works with that based on my discussions with the company. So they've got a lot of experience. They certainly would be, more than happy to make a presentation. They can probably present their product a lot better than I can, but in terms of what it can do and where it works best. It'll be interesting, I think, to kind of keep track of what Damascotta is doing as well. I mean, I think they've already purchased their Watergate, so I don't know how many linear feet they purchased. They do have on their website, if you're interested, there is a presentation by these folks that's linked on their website, and they also talk to another company with a different type of a system that they were looking at for their waterfront area. So,
Well, I'm just curious, as this goes up, and there's going to be water that's coming in, that there are a lot of working waterfront docks in that same area. Will that make the water higher than it would have been? I mean, it's got to go somewhere.
well, infinitesimally, I think it
Okay.
will make it go higher. I mean, it's just, yeah, you're right. It's got to go higher somewhere, but it's such a large volume of water that I think
Okay.
the amount that you're going to see it go up over on the dock across the way is going to be relatively minimal, because it's, if you look at the amount of water that would have gone through over Abner Point Road without this product in place, in the big scheme of things, it's still a relatively small amount of the, we're dealing with the ocean, right? So it's still a relatively small amount.
The reason for my question was I recall last January, they were putting bait barrels full of water to keep the dock down, so that the water wasn't going to be raising it up.
Gotcha. Yep.
So, just was curious.
So there are still other challenges here on Abner Point Road with the private properties on either side. So there's several buildings that are, finished floors are relatively low, right next to the boat launch, for example. A couple buildings that are right around 8, elevation 8. This type of a product could be deployed in front of those buildings potentially. I think it would be challenging just because of the nature of the terrain in there, and rocks and seaweed and things, to try and get a good fit to the ground. To me, something like this would be best deployed kind of along one lane of the road, and then you would leave one lane open. Obviously, that's not ideal, and people are going to have to play nice, and if people want to drive in and out of there, they're going to have to take turns and all that kind of stuff. But it minimizes the flooding and the damage and everything else to the road, to the buildings on the other side, et cetera. So, yeah.
Will, if this works for Abner Point Road, would it work over on the Bethel Point Road?
So the thing that makes it different for Bethel Point Road is that we've got a big culvert underneath that, which water's going to keep rolling through there unless you block that culvert off. And it's a little bit different volume of water there. If you block that culvert off and keep that whole cove on the other
Right.
side of the road from filling up, I think you would potentially cause problems with that. And similarly with Dingley Island Road,
The
it
water
doesn't.
goes both ways.
Yeah, it doesn't
Unpredictable
necessarily
ways.
work for that situation. If you were to implement this at Abner Point Road, I would recommend it in addition to the tide gate valve, so you're not allowing water to go back up through that culvert because it basically defeats the purpose of it. So you kind of need to do both of them at the same time to get the biggest benefit out of it.
What are the cost comparisons between purchasing something and deploying something like that and raising the road?
It's coming next. So, not quite next, but I'll get to it in a second. So this is just a plan showing kind of where you would deploy that type of a system, kind of along this side of the road, which would basically leave, the other lane open. In this case, we've got Luby Lane here. The boat ramp is here. Town parking lot here. So that just gives you an idea of how that might be deployed. So this is the raising the road option. Again, we're looking at the 3.9 feet from highest astronomical tide, which roughly raises it about 2.2 feet in this case from the existing road. There's a little bit of a weird hump in the road here, but and then the FEMA flood elevation here is much higher than above that. In my opinion, well, I guess with enough money and everything else, you can do anything you want. I think it would be very difficult to raise the road to the FEMA flood elevation in this location. Less difficult over at Bethel Point Road because you have less impacts to private property and things like that on either side. If you told me this, what's the cost to raise the road to elevation 14 at Abner Point Road, I can come up with a cost, I guess, but it's just so challenging with some of this existing private property. These two structures here, this house here, I think the boat ramp becomes much more of a challenge. Raising it up like the road like we've got it, roughly 2.5 feet, 2.3 feet above what it is today, actually may help the boat ramp out a little bit. It actually improves the slope of the boat ramp a little bit better than what it is today. But you raise this up to elevation 14, I think you're going to make that boat ramp a lot more difficult to access. Potentially, if you rebuilt the entire thing, yeah, maybe we'd be able to get something to work there. But so there are a lot of challenges with raising the road to the FEMA flood elevation in this location. Let me see here. Come on. There we go. So this is the portable flood barrier and the tide gate. Flood barrier, I think this is a conservative cost. This is actually looking at the 50-inch barrier for the entire 500 feet here. Tide flex valve, miscellaneous costs. I think we'd replace the culvert while we're in there. So $329,000 total project cost. That includes a contingency not on the flood barrier, but the tide flex and miscellaneous and engineering costs. So 329 versus 1.5. This is a little bit lower than the other ones on Bethel Point because we're not replacing a massive culvert like we were over there. That culvert adds a huge amount of cost to that project. So still not insignificant, but it's And then the other thing that this doesn't deal with is the ancillary costs of the private properties that are affected by you raising this road up. We're reconnecting driveways where there are existing driveways, but we're not raising structures and all of that. So there's a lot of other costs that would likely occur, and the town would need to have to decide how they want to deal with that. If it's being caused by a town project, is there I don't know all the answers to that in terms of the private property owners, you know, where they, if, you know, because now all of a sudden your road's now 2-3 feet higher than the structures on either side. I know there's been discussion, I've met with one of the property owners to talk about their properties and the two structures next to the boat ramp. I know they would like to raise their, just raise their entire lots and raise the houses that way. Based on my knowledge and experience with permitting and regulatory agencies, I don't think that's feasible. I think if they want to raise their structures, they're going to have to raise them up on piers. So there wouldn't be, you wouldn't be raising the lot, the elevation of the lot, the ground of the lot. You would just be raising the structure up in the air. And I'm involved with several projects similar to that further south that we're looking at right now down in Biddeford and in other locations where they're basically raising their houses up on posts, similar to what you might see down in Florida or North Carolina, South Carolina, some of those places down there. So I think you would, I'm not sure you could permit it where you would actually fill the lot up and, you know, add fill to the lot and then raise your house up that way or your structure up. So there are a lot of other costs that are kind of on either side of this project when you start looking at raising the road in here. Bethel Point Road, much more amenable because there's just not as much private structure there. There's a couple roads to tie in on either end, but you're not having to worry about people having to raise their houses up in the air or that type of thing. So I think if you started looking at all those costs, that cost would go up substantially. Not necessarily all the town cost, but I don't think we can necessarily move forward with something like this without consideration and meeting with those property owners and, you know, figuring out what's going to happen there. This does include a cost for reconstructing a portion of the boat ramp. It also includes a fairly substantial cost for raising the overhead utilities. The overhead utilities would have to be put up on taller poles. We've got a $300,000 number here just to replace the poles and raise those utilities, because you raise the road up, then you're not going to have as much clearance between the bottom utilities and the top of the road, so you've got to raise those up in the air. So it's a fairly substantial cost. There's similar things you have to think about over on Bethel Point Road, but there's actually fewer poles. The poles over here on Abner Point are spaced a lot closer together, so there's more poles. So
The miscellaneous costs.
miscellaneous costs there's a lot of different things in there. Instead of breaking them all out, there's erosion control, there's some other things. So what my note down at the bottom is, so what else do we include in there? Just contractor costs like mobilization when they come out to do a project. There's a mobilization cost, traffic control, erosion control, those types of things. Harder to put an exact number on that, so we use our engineering judgment in terms of typical percentages of construction cost to come up with those numbers at this point.
Based on the recent past with weather, if you were to go with the portable flood barrier and the tide gate valve option, how many times a year would that likely have been used?
More each year.
Potentially, yeah, I
On
mean,
most recent data then, if that's, yeah.
I mean, yeah, I would say 2 to 3 times maybe this past year.
And the life of those systems, you're saying, is 20+ years?
Yeah, I mean, as long as they're treated well and you're not just throwing it over onto the side of the road till the next one and then pulling it back. I mean, if you pack it up and dry it out and pack it up into its crate and then deploy it again the next time, I think you would probably get 20 years plus out of that type of a system.
There'd have to be some operating costs, just, you know, you can't just have this thing appear. And there's probably some training and,
Oh, absolutely.
I mean, they make it sound like it's easy to deploy and my guess is,
And you've got to have the people there to deploy it when it needs to be deployed.
right.
So it's not like we have a full, public works crew here in town. I mean, some towns have a public works crew that could potentially be responsible for that. There would have to be, consideration of that for sure. It's not a perfect solution, but to me, it was one that I felt like I really need to present to the town, given the costs that we're dealing with here for the different options. And it feels like, to me, that it could be a good temporary solution. The other thing is it could be used in other locations too. There are other locations in town where it potentially could be of value. It doesn't necessarily work at Bethel Point Road. It doesn't necessarily work at Dingley Island Causeway. It could work in the back parking lot here to protect the town office. Not to say that you couldn't just buy another one for the town office or wherever, but there's other places in town that this type of a solution might be a benefit.
But likely, the time that it would be a benefit would be, everybody would need it at once, right? So,
Right, I mean, yeah, if you need it over at Abner Point, then you probably need it
yeah.
other places in town too. Kind of depends on the flooding event though. If it's a flooding event that is not wind-driven storm surge, that's, elevation 14, then you might not need it over at Abner Point, and it could be used somewhere else. These guys that do this, I mean, they have all kinds of options that are available that would change the cost. I mean, the deployment crate's relatively simple solution, but you have to be able to have something to lift that thing up into the back of a 1-ton truck or whatever. They also sell kind of turnkey solutions where you buy a trailer that's preloaded with this thing, and you just hook it onto the back of a truck and tow it down the road and roll the stuff out. So there are different options. I'm presenting the basics here. If we wanted to proceed with that, we'd want to definitely have more discussion with them.
Are there any other questions? Rick,
So,
you live on Ruby Lane. Did you have any questions specific?
Not at this time. I think he's answered pretty much everything today.
Great.
Are you down Ruby Lane or?
Yeah.
Yeah, okay. Now, did you get flooding coming in from the other side?
So what I kind of observed is I saw that it almost seemed like the water came from both sides, and they just met at the road. It wasn't like
Okay.
it was specifically blown over Macro Cove and coming through. And then I saw basically come over the road, come out of the swamp, and then at the end of the driveway, all kind of converged at once. It wasn't like one thing had to another. It was all in the same 15, 20 minutes.
So that's a little bit different than what I've heard. I mean, and maybe this doesn't work as well in that situation, if it's coming from both sides. Because if you put it on both sides of the road, then you can't get through there anyway, right? And these things are relatively wide too, so they are gonna take up a lane. The lower the height, the narrower they are, but, so that's interesting to hear. I hadn't heard that at the
I think
last.
we had some pictures kind of showing that too, time-lapse pictures of it.
Yeah.
You had sent them last year to me.
Yeah, I think so.
I also had heard that it was taking water coming down the hill. Doesn't it take the water into that coming down from Abner Point Road?
Yeah, it does. It takes some groundwater, you know, from rain,
Yeah.
rainwater.
Okay.
Was that picture of Bethel Point taken at the peak, you know?
It's definitely not at the peak, because it was over the road. I think there's a video out there for that too.
Yeah, these,
Lots of debris on the incoming side of the culvert.
Yeah, I couldn't put my fingers on the video.
we've had a project going where we have people taking pictures at the high tide each month. And I believe this one was taken possibly by Deirdre, who just walked out for a moment, at one of the high tides where it went over. Or maybe Nancy, when you went out, I'm not sure.
No, I mostly do Dingley Island,
Right.
and it definitely went over.
But another thing, just as we're winding up, I'd like to kind of keep in mind, at some point, we're going to have a lot of work that's going to be done, need to be done all over town. And there's going to have to be some kind of an evaluation process and prioritization. And one of the things that we're hoping this information will give us to put the town better, to figure out how to evaluate. In some cases, much of our flooding is storm surge flooding, and it drains out within an hour or two, versus places that stay flooded for days afterwards. So those are all considerations, I think, as we start to get more in detail about taking care of the problems and spending money on the problems that are going to be part of the consideration. How many do you fix? How many projects do you have to retreat? This is something we're just starting to think about. Josie?
How did you decide on these two, or what criteria?
We have a list of, now this was a list that we got from a very general sea level rise overlay, and there were 5 town roads that were going to be affected by 1 to 2 feet of sea level rise. The 5 roads are these 2, Dingley Island Bridge, Lowell's Cove Road, and Basin Point Road. Basin Point Road was the first project that we did such a study, and that was done in 2018. And it told us that we needed to start looking at more.
What about Lookout Point?
Lookout Point is a landing, yeah, the landing down there. And we have a study down there, as well as Garrison Cove. So those are 2 landings. We are looking at other landings in town as well. But here again, just as what Will did, we're going to start looking at what some of the options are and how we're going to have to start thinking about it. I hope that answered your question, Josie.
Totally, thank you.
Yeah.
So, yeah, and I guess this flood barrier thing, it would have to be with agreements from private property owners, but thinking of Abner Point Road in particular, I mean, there are ways that we probably could deploy something like this kind of along the edge of that wetland. Kind of, it's not perfect, it's not a paved road, but I think you could install it on the native ground there. And it's just, you start getting into that and it's a lot harder to deploy all this stuff and get it all deployed in time and everything. So, I don't know, I mean, it's,
This will become, I think, more of a specialized discussion to have
Yeah.
as you bring projects for completion. I mean, projects to actually do the work. That becomes part of the conversation, I think, at that time.
yeah.
And then we can hear the input from everybody that lives in those areas.
You can't raise all the roads, so that's gonna be the challenge. I mean, Luby Lane is it private all the way, or is it? Yeah. So the town can't spend money on raising Luby Lane or the entire length of Luby Lane. They can spend money on bringing Luby Lane up to meet a raised Abner Point Road, but they can't necessarily extend that all the way out to the end of Luby Lane. So, you know, at some point,
Yeah, and I'm glad you brought that up. 68% of our roads in town are private. And and as everybody knows, the town cannot spend money on private property. What we are trying to do, and if anybody here lives on one of those roads, we're trying to find out names of road association and contact people, because we want to start doing some education about what you have to start thinking about on your private road for maintenance. Also, if you have the right type of road association, there will be time in the future where grants will come down. The grant that we applied for in the spring was open to private road associations, if they were a statutory type. So this is all information we want to start studying more and putting out to the residents so they know about it. So if you know of a road association that you're part of and would like to put that down before you leave tonight on the pad, we'd like to continue to build that database so that we can reach out to you and as we go forward on this. And we get so excited about this because we're thinking that could be helpful in other ways where the town is trying to reach out in emergencies to people who live on private roads. So we'd love to have you add any information that you could. And if you forget to do it tonight, you can always send it to conservation@town.harpswell.me.us. So I think, did you have anything else, Will?
no,
That was really interesting.
Very good.
What's your
Yeah.
timing for doing the completion?
So our next step on this is to write up the report. I think our goal is by the end of this year, because we're probably already a little bit on the late side of that.
Right.
But we need to wrap up the report for this project. And then the next step is to move on to Dingley and Lowell's with I'll work with Mary Ann to schedule a public meeting on those roads, and I think the report on that is due in
March.
March
So
time.
for this particular project, Will's going to write up the report. We have to then take it to the select board. They have to accept it, that the work is done, and sign off on it as being completed. And we are going to try and get that done this year,
Yeah.
which gives us a couple weeks, right?
Happy New Year.
Okay, and then the next project we were just talking about is the Bethel Point Road one, Dingley Island and Lowell's Cove, that we need to have completed by the end of March.
Yeah.
So we will be having the same type of meeting prior to that completion. And we have been just reaching out to the people directly reaching out to the people who are affected by those roads. But I think possibly, as there's more interest, we can start posting it just on the town Facebook page to make anybody aware of it who would like to attend.
And then we're also, as I said at the beginning, we're working on 2 other kind of damage repair projects that are not directly related, but still kind of similar, dealing with sea level rise and storm damage. And we're, again, we are dealing with regulatory agencies and trying to understand and see where they're coming down on these things now in terms of what's permittable and what's not permittable. And it's becoming a lot harder to just, put down riprap and call it good anymore. And that makes it hard from our perspective, because riprap, we understand the challenges and the concerns that regulatory agencies have with riprap, but it is by far probably the best solution out there for protecting against storm surge, and dealing with that. And some of these locations are very challenging to use the new terminology that you hear, the living shorelines or the green infrastructure solutions just don't hold up as well against storm surge. I mean, that site at Ocean Street there by the Giant Stairs, Trail to the Giant Stairs, I believe that's the one that has the peak flood elevation that's like 26 feet, I think. Because it's wide open ocean right out there beyond that. So there's a huge fetch there for the waves to come in on that. And to design something that's not riprap is just, it's very challenging.
And I think Maine Geological Survey is doing a lot more. They're combining riprap with other things, so that it might not be one thing only, and they might be terracing some of the things.
We're looking at a hybrid solution that has toe stones and then a greener solution up on top of that. It's still, though, that's a really tough site, because the bedrock underneath kind of slopes down to the ocean, and trying to get rocks to stay up there on that, where that eroded, it's not easy. I've been scratching my head on that one for a little while now, trying to figure out how to fix that.
Okay, well, I thank you all for coming,
Thanks.
and we'll be in touch.
Yeah.